What's up, guys? This is Professor Al Jafri from ITI1120, and today we will continue our lectures and we're gonna cover the following topics. First, we will start by whatever referred to as the flow of execution, and then we're gonna hammer the topic or the area of execution control structures in more details. So, the flow of execution is determining the order at which the Python interpreter execute each single line of your code. To understand that better, let's take a look at the following example. So let's suppose that we have this program and we would like to determine what is the order in which these lines of code are processed in Python. So remember, I told you that Python execute the line of code sequentially, but we have to understand that in case of a function definition, the Python will scan the first line of code and skip the indented code block. So in our example here, we have two function definitions. So what does that mean? That means that Python will read this line and then go to this line as well, and then after that we'll go to this line, which is line 9, at which it's a declaration of a global variable called n. It's equal to 5, and then after that we can see that we are making a function call to the function square where n is equal to 5. So after that we go here, we go to the body of the function square, and as we can see we are making another function call to the function power. So we're gonna go back to line 1, and in line 1 what we're gonna do is calculate what, guys? Calculate the n to what? To power 2, and then after that we go to return y, and the value of y will be returned in a here, okay? And after that we're gonna go to line 7, and then from line 7 we go back to line 10 and complete our assignment, and after that we go to line 11 and print the results. To understand that better, let's visualize the execution of this code. Okay, so as I told you, so Python first will read the lines sequentially. Starting by line 1, Python will say, okay, this is a function definition, so I'm just gonna read the function definition and I'm gonna skip the indented code block. So as we can see, we jumped to the another line, which is like line 5, and which happens to be like another function definition. So what does that mean? Python will skip the indented code block and go directly to line 9. Okay, so at line 9 Python will create a global variable called n and assign a value of 5 to n. Okay, then it's gonna continue sequentially, therefore it's gonna go to line 10. At line 10, as you can see, it's a function call to line 5, therefore we're gonna go back to line 5. And now, because we are in line 5 and we need to determine what is the value of square 5, we have to go inside the indented code block for the function square. Therefore, from 5 we're gonna go to 6. And here, as you can see, it's another function call, so therefore we have to jump back to 1. Okay, that's what's gonna happen. Now after this, what's gonna happen is, it's a function call at which the values of the power function are 5, which is n, and 2, which is the constant here for p. Okay, now what's gonna happen? It's gonna go and execute the indented code block of the power function, and then go to line 3, and after that we are seeing that 5 square is equal to 25, and then it's gonna go back to line 6 and assign the value to a. So that's what's gonna happen. Okay, so I'm gonna go back to line 6, and after that I'm gonna go to line 7. Okay, at line 7 what I have to do, I have to return the value of 25 to results. Okay, so I'm gonna go here to line 10. Okay, and at line 10, the next line to be executed is print result, which gonna print what? 25. Okay, so what is the best answer in this multiple choice question? Apparently is option E. Is that clear, guys? I hope it's clear. So let's get back to our presentation. And okay, so we have covered the basic iteration, and the general format of iteration is implemented through the for loop statement, at which the variable sequence must refer to an object that is a string, list, range, or any other container type that can be iterated over it. So the Python runs the for loop and assign successful values in the sequence to variables, and then execute the indented code block, okay, for every value in the variable. After the indented code block has been executed for the last value in sequence, the execution resumes with the statement in the non-indented statement code block and has the same indentation. As you can see, this non-indented code block has the same indentation as for the for loop. So the for loop and loops in general have many uses in programming, and there are different ways to use loops in Python. So let's cover those usage patterns. So the straightforward iteration pattern is to iterate explicitly over a sequence. So far we have used the for loop to iterate over the character of the strings, as we can see in this example. So as we, like in this example, what we're gonna do is we're gonna print each character of this string, okay? And that applies for any kind of sequence that we can iterate over it. So another example of the sequence is what, guys? Is the list. And as we can see, if variable word in the list here, so what we have to do to what, guys, to implement the indented code block, which is in our case it's another control if statement, which will not be executed as long as the condition is true. So if the top is in word, so that means for each variable in that list, if that variable, which is a string in each item of that list, contains the substring top, I'm gonna print it. Otherwise, I'm not gonna print it. So let's take a look at the word here. We have the word stop. Then we're gonna check if the top is included in this top. So that's why we're gonna print it. Now in desktop, the word is desktop, and we're gonna check yes, top is included. So we're gonna print it. At post, the word post, top is not included, therefore we will not print it. And finally at top, which is exactly the substring that we're looking for, and therefore we're gonna what? We're gonna print it. Okay? So iteration through an explicit sequence of values, okay, is the simplest usage pattern for a for loop. Now, as we can see here, we can use the end sequence, okay, to print all the list items in one line, where each line is separated by just a space. Now, this is a straightforward example of an explicit loop pattern, but we can use another loop pattern. So instead of iterating through the items of the list bit, we can iterate through the index of the list bit and achieve the same results. So let's take a look at this implementation. So for I in range length bits. So what does that mean? So for each variable called I in range length bits, so what is the length of that? So we have 1, 2, 3, 4. So we can, like, the length of that list is 4. So for each item starting from 0 to 4, what we're gonna do, we're gonna print the the item by using what, guys? By using the index of that item instead of printing the value of that items. So note that how the range and the length functions work in tandem to generate the indexes of 0, 1, 2, and the 3 of bits. Okay, so what does that mean? So at the first iteration, which is bits 0, I'm gonna print cat, then end. So that means I have to stay at the same line with a separation equal to a space. Then after that, I will be equal to 1. Then I'm gonna print dog. Then I will be equal to 2. I'm gonna print fish. Then I to be equal to bird. And then I'm gonna print bird. Okay? So that's exactly how it's going to be printed. Now, the second approach, which is like iterating over an implicit sequence of indexes or numbers, is more complicated and less intuitive than iterating explicitly over the items. So why would one use it? So in other words, why we are complicating ourselves? Well, there are some situations which it's necessarily to iterate through a sequence by index rather than by the value. So let's consider the problem of checking whether a given list of numbers is sorted in an increasing order, okay? So what does that mean? That means that we have to develop a function called check sorted, and the sorted takes a list of comparable items as an input, okay? And returns true if the sequence is increasing and false otherwise. As we can see, the input argument for check sorted is a list, and it will check if that list is sorted or is the items on this list is placed in ascending order, and therefore it's gonna return true. However, here, which is a 3, is not arranged in the increasing order, therefore the check sorted should return false. So check the adjacent pair are correctly ordered or not. This is an idea. So let's implement this by iterating through the items explicitly on that list. Okay, so define check sorted and list, and the type of contract is what, guys? Is simply what? Is simply list to boolean. Okay, so for each number in list, we would like to compare the number with the next number in the list. Okay, so how we can do that, guys? Actually, we're stuck. How we can know the second number in the list? The problem in our case here that we don't have any way of checking the next item in the list if we are iterating explicitly over a sequence. So if we iterate through the list indexes rather than the list item, we do have the way. Okay, guys? So how to do it? So for I in range the length of the list, so we would like to compare the first item with the second item. So we can convert this algorithmic implementation to a what, guys? To what? To a real implementation. So after that, what we have to do is to compare. So to compare if that next item is greater than or equal the current item, so the list is correctly ordered and we should continue. Else it's not correctly ordered and we should return false. Therefore, okay, so guys, it's very simple. So what we have to do is we have to say if the list I, so for each I starting by 0 until the length of the list minus 1. Now, please note, why did we use minus 1? Because in our implementation, as we can see here, I used I plus 1. That means at the last item, I'm gonna get out of range, and this will well, guys, this will cause an error, okay? So to do that, to avoid that, so if the item in this list is greater than the next item, what we have to return false. Other than this, we have to continue what, guys? Continue our loop, okay? And at the end, we can indented the return true with the 4, so it will be after the body of the 4, and we're gonna return it true, okay? So what does that mean? That means in the following function call, we're gonna start by, what is the length of that list? 1, 2, 3, 4, 5. So we're gonna iterate from 0 to what, guys? To 4, okay? So if items at 0 is less than item at 1, we're gonna return false. Is that the case? No. 2 is less than 4. So we're gonna go and then increase the offset by 1. If item at 1 is greater than item at 2, so item at 1 and item at 2 greater, no. So we're gonna what? Increase I. Now, if item at 2 is greater than item at 8, we're gonna return false, and that's not the case. And if item at, if item at index 3 here is greater than the item at index 4, we're gonna what, guys? We're gonna return false, which is not the case. So the loop will end up and we're gonna return true, okay? Okay, so as an exercise, I want you to pause the video and implement a function called arithmetic that take a list as the input and return true if the numbers in that list are in an arithmetic sequence. What does it mean in arithmetic sequence? That means you can find the way at which this list is increasing or decreasing. So as we can see here, we're adding 3 each time. That's why it's returning true. And here, as we can see, like at this case, we're not adding 3. For each other pair, we're adding 3. However, here, we're not adding 3, therefore it's returning false. For an item with one list, the function should return true. Okay, so to implement this, function, first we have to check if the list has one item. If that's the case, we have to return it true, okay? Now, what we have to do, guys, is to understand that the given list has an arithmetic pattern or not. So how to do it, guys? Simply by, finding the difference between each adjacent pairs. So that's exactly what we are doing here. So, and then after that, we are iterating over, guys, over the items using their index rather than their actual values. And please pay attention that we use the length -1 because we don't wanna get an out of range issue. Okay, so what does that mean? If items if the difference in each consecutive pair is not equal to the difference of the first pair, we're gonna return false. Otherwise, we're gonna return it true. So in this case, as we can see, the difference is determined by 3 because 6 minus 3. Then we're gonna iterate over these two pairs 10 minus 6, which equal to 3. That's why we're gonna skip the return false. And 12 over 9 is 3, so we're gonna skip the return false. And 15 over 12 is equal to 3, and that's why we're gonna skip the return false, and we're gonna return it true. In the second case, as we can see here, when we reach to comparing this adjacent pairs, 11 minus 9 is equal to 2. Therefore, this condition is true, and therefore we're gonna return false. Note that in a list of one item, that means if that length of the list is less than 2 or is equal to 0 or 1, I'm gonna return true. Okay? Another useful loop pattern is called the accumulator loop pattern, at which we can assign a variable. That variable can be used for multiple purposes. In our case here, we would like to write a code at which we can find the sum of a given list. So here we will assign a variable. We name it the accumulator result. We assign it to 0, and after that we keep iterating and adding the new value of result in order to finally get the sum of the numbers in my list. So as you can see here, so num is equal to 3. That means the result is equal to result plus num, which is equal to 3, because 0 plus 3 is equal to 3. Now number is equal to 2 and the result is equal to 3. So the new value of result will equal to what? To 3 plus 2, which is equal to 5. Now at 7, we're gonna add 7 to what, guys? To 5. Okay, and we're gonna have 12. Now after that, at 1, we're gonna add 12 to 1, and the result will equal to 13. And finally, we're gonna add 13 to 9, and the result will equal to what, guys? 22. Okay? Some other guys can say, okay, we don't need to use the accumulated loop pattern. We can use the built-in function sum, and we can sum that list. Okay, and that's it. So this value that you identified is called the accumulator. And please note that we can use a shorthanded. So the shorthanded arithmetic operation is result plus equal to num is equal to result plus num. Okay? And similarly, result minus equal to num, that's equal to result minus num. Okay? Now, what if we want to obtain the product, but here we don't have any built-in function to calculate the products of each item in the result. Therefore, we have to write our own program to do so. And in this case, if I initialize the accumulator to equal to 0, this is a common mistake. Please be aware of that mistake, because we are multiplying here. The final result will equal to 0 regardless of iterating over each item in the list. Okay, so this will give me 0. So instead of initializing the accumulator to 0, such as the case of the sum, we're gonna initialize the accumulator to what, guys? To 1. Okay? After fixing this mistake, we're gonna multiply the number 3 with what? With the initial value of the accumulator, which is 1. So the new value of result will equal to 3. Then after that, we multiply 3 with 2, and the new value of result will equal to 6. After that, we multiply 6 with 7, and the new result value will equal to 42. Then we multiply it with 1, it's still 42. We will multiply it with 9, and the result will equal to 378, and that's it. Okay? Now, I want you to implement a function called factorial that takes a non-negative integer as an input and returns the factorial of that number. Remember, the factorial of 1 is equal to 1, the factorial of 0 is equal to 1, the factorial of 3 is equal to 6. And how it's calculated? By multiplying 1 plus multiply by 2 multiplying by 3. The factorial of 6 is equal to 720, and it is calculated by multiplying 6 multiplied by 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1. Okay, so how we can implement this function? I want you to pause the video, try to solve it in your own, and try to incorporate what we understood in the previous slide using the accumulator looping pattern of the multiplication and apply it in this case. Alright guys, so I assume that you have solved this question, and as we can see, the type of contract here is number to number, okay, and it retains the factorial of the input argument. So we're gonna start what, guys? We're gonna start the accumulator to 1, and what we have to do, guys, as simple as that. Okay, we should iterate from 2 to n plus 1. Why we are doing that? Okay, because guys, we are gonna implement it the reversed way. So suppose that I have a 3 factorial, okay, of 5. So the result will equal to 1 at the beginning, and then we have to iterate from what? From 2 up to what? Up to 5 plus 1 up to 6, and we're gonna skip 6, so it's gonna be up to 2 to 5. Okay guys, so what's gonna happen at the first iteration? Okay, so we will multiply the result, which is 1 multiplied by 2, and that's equal to result. Okay, so then at the second iteration we will multiply 2 multiplied by 3, and okay, and this will equal to my result. Now at the third iteration, what I'm gonna do, I'm gonna multiply 6, or let's keep it this way. I'm gonna do like, this is 1, okay, and at the second iteration I have the previous value of result 1 multiplied by 2 multiplied by 3, and it's gonna be multiplied by 4, and at the final iteration this is equal to result, so I'm gonna multiply the value of result to 5, which is 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by the new value of I, which is 5, okay, and then I'm gonna return it, which is basically the factorial of 5. Okay, I hope it's clear to you guys. Okay, another exercise here, which is to build a function called Acronym, and the function Acronym will take a string as a phrase, okay, and will return the acronym of that phrase. So in other words, the type of contract is a string to string, and the function will do what the following: will strip each first character of that string and will give you the abbreviation for it. So random access memory, it's RAM. Okay, so how to solve it, guys? Well, that's something very simple. So to solve it, we have to do the following. First, we have to find a way to convert that string into a list, and after that, what we have to do is to use the accumulated loop pattern. But remember, now we need to concatenate over a string, or to do the addition over a string. So what should be the value of the accumulator? The value of the accumulator has to be an empty string, not a blank space, an empty string. Okay, so let's take a look at the solution. So Okay, so the function will take a phrase as the input argument, and then we split that phrase into a list of words. Okay, then after that we're gonna assign an empty string. Okay, so after initializing the accumulator to an empty string, we're gonna iterate over each word in that list. And at each iteration, what we are doing is we are stripping the first character, making sure it's capitalized and concatenated to the string. At the end of the day, we're gonna end up having the abbreviation of that phrase. I want you also to write a function called divisors that takes a positive integer n and returns the list of the positive divisor of n. So the 1 can be divided over 1, 6 can be divided with 1, 2, 3, and 6, and 11 can only be divided by 1 and 11. So in order to solve this kind of a question, you have first to use the accumulated loop pattern, and since we are here, we would like to concatenate over the list. How to do the concatenating over the list? We should use the function append. If you remember, the function append will add like a new item to the end of that list, and we should start the accumulator here as an empty list. Okay, and we should use the mod in order to determine if the given number is can be divided over our targeted number. Okay, so let's take a look at the solution. A point of interest is the type of contract here, which is number to list. So we start here by initializing the accumulator to an empty list. And for I in range 1 to n plus 1, which is y, we would like to make sure that the number is included. That's the case of 11 here. And the 11 was what? Itself, it's a divisor. So if the number mod I equal to 0, that means if I is a divisor of n, so I have to append that number to my empty list. So let's take a look at the input argument 6. So we start by an empty string. So our accumulator here, in my case, result equal to an empty string. Then at the case of I'm iterating from 1 to what, guys? To, like, we have n plus 1 equal to 7. That means I'm going to iterate up to 6, and 6 is included. Okay, so first I'm going to check if 6 mod 1 is equal to 0, and that's the case. So 6 over 1 is equal to 0. Therefore, I'm gonna add the new result will equal to 1. Okay, then after that, that's why I am appending 1 here. Okay, now the new value of I will be equal to what? I will be equal to 2. And then what I have to do is to check if 6 mod 2 is equal to 0, which is the case. So what I'm gonna do, I'm gonna run to this line and append I, which is I in my case is 2. So therefore the new value of result will equal to 1, 2. Okay, now I'm gonna go I will equal to 3, and I will check if 6 mod 3 is equal to 0, and that's the case. So the new value of result will equal to 1, 2, and then I'm gonna append 3. Okay, then I'm gonna check 4. Apparently 6 mod 4 is equal to what, guys? Is not equal to 0. Okay, because it's gonna equal to 2, sorry, it's gonna equal to 2. Therefore I'm gonna skip number 4. 5, 6 mod 5 is equal to 1, that means it's not equal to 0, so I'm not going to append 5 as well. Now I'm going to reach to 6. 6 mod 6 is equal to 0, okay, because the answer is 6 and the remainder is 0. Therefore, my new result string will equal to 1, 2, 3, and finally 6. Okay? So remember, when we would like to do a list concatenation, we should, as you can see, we should use an empty list. Okay? I hope this is clear for you guys. All right, so let's move to another loop pattern. Is called the nested loop pattern. So let's suppose that we have a function called nested, and the function called nested will take a positive integer here and print 5 lines, at which each line is iterated from 0 to n minus 1, and we are using the end string to determine that it's it's a space between each item, and after that we are printing a new line, as you can see that. So what we can use is the following. So we can say for I in range n, print I with the nth, so that will print the first line. So if I did the following for I in range, for j in range n, and for I in range n, print I int, what's gonna happen is I'm gonna print the numbers from 0 to 4, then I'm gonna print them again at the same line, and this is not our case. So we, as you can see, we have an outer loop and an inner loop. So what, in order to solve this, what we have to do, guys, is to, whenever we finish the inner loop, we have to tell Python to go to a new line. So how to do that, guys? Okay, so by adding a print here. So what's gonna happen for, let's take an example, number 5. Okay, so for j in range 5, and the indented code block is for I in range 5, then this inner loop will make sure that I'm printing the numbers from 0 to 4. And when it's done, I'm gonna what, guys? I'm gonna open a new line, and then the value of j will equal to what? To 1. Then I'm gonna repeat the same thing again. Okay? Then the value of j will equal to 2, and then I'm gonna print the third line. The value of j will equal to 3, I'm gonna print the fourth line. The value of j will equal to 5, to 4, I'm gonna print the fifth line, and that's it. Now let's suppose that I would like you to implement a function at which, or called nested2, and it print the numbers at line 1, 1 item, at line 2, 2 items, at line 3, 3 items, at line 4, 4 items, and at line 5, 5 items. Can you solve that? So when j equal to 0, the inner loop should be print 0. When j equal to 1, the inner loop should print 0 and 1. When j equal to 2, the inner loop will print 0, 1, and 2, and so on. Okay, so what does that mean? I have to range up to the value of j. Okay, so for j in range n, and for I in range j plus 1, then after that I'm gonna print I and use the int equal to a space string to make sure that like I'm printing the items at one line and then I'm moving to the next line. Assuming n equal to 5, what's gonna happen is I'm gonna iterate at the outer loop till 4, and at the inner loop I'm gonna iterate each time from 0 to j plus 1. That means at the first iteration for the inner loop, I'm gonna iterate from I equal to 0 until 1, and then I'm gonna print just one item, which is 0. Then I'm gonna print a new line. I'm gonna increase the value of j to become 1. Then I'm gonna iterate from 0 to 2, and then I'm gonna print the items 0 and 1. Then I print a new line, then increase the value of j to become 2. Then I'm gonna iterate from 0 to 3, and then I'm gonna print the items which are 0, 1, 2. Then I'm gonna print a new line, and then I'm gonna increase the value of j to become 4. Then I'm gonna print 0, 1, 2, 3. Then I'm gonna increase the value of j to become 4, and so on. Another statement to do the loop in addition to the for is called the while loop. Okay, so with the while loop in hand, as well as a few additional loop control structure, we can develop more useful loop patterns. So what's the while loop? The while loop is something, is a combination of a for and an if statement. So while the condition is true, in the if statement, we are what? We are checking if the condition is true and executing the indented code block one time, and then we're moving to the non-indented statement. But with the while, what we're gonna do is we're gonna repeat doing the non-indented code block as long as the condition is true. As you can see that the difference in the flowchart between the if statement and the while statement is that I keep checking the condition, and I keep re-implementing, re-executing the indented code block until I get to the false. Then I have the non-indented state. Take a look at the Fibonacci sequence. The Fibonacci sequence starts with an integer 1 and goes on over by applying this rule. The current number in the sequence is the sum of the previous two numbers in the sequence, and actually the Fibonacci sequence is named after the scientist called Leonardo of Pisa, and this scientist developed a sequence model that can predict the growth of an idealized rapid population. So what does that mean? If I have one and one rapids, I'm gonna end up with two rapids. So 1 plus 1 will give me 2. Then after that, I can add the 1 plus 2 to have 3 rapids. Then the 2 plus 3, I'm gonna have 5 rapids, and so on. So as you can see, the Fibonacci starts by what? The Fibonacci rule is, is based on the sum of the previous two numbers in the sequence. Okay, so now I sum the previous two numbers, I'm gonna get 8. I sum the previous two numbers, I'm gonna get 13, and I'm gonna sum the previous two numbers, I'm gonna get 21, and so on. Okay. So having this, let's take a look at a beneficial example of using the while loop to implement the Fibonacci. So our goal is to implement the first Fibonacci number greater than some integer pound. Okay, so what we have to do, if the condition is true, we need to generate the next Fibonacci number. So long story short, so what's our goal here? So our goal here is to build a function. This function basically will take a number, and this number will represent a pound, and we would like to find the smallest number that is greater than the pound. So return the smallest Fibonacci number greater than pound. We would like, so if the number that, assuming that we called Fibonacci 15, what does that mean? That it will retain the smallest Fibonacci number greater than 15, which is 21. Okay, that means if I have a 15 rapids, eventually I will get 21 rapids. So let's assume that I have 24 rapids. So what is the smallest Fibonacci number greater than the pound 22 is 34. So how to solve that? Guys, as we can see, the implementation of Fibonacci is based on the summing of the previous two numbers in the sequence. So we have to define two accumulated values. The first value, we can name it previous, and current to point to the previous and what, guys, and the current value of the Fibonacci. So while the current is less than pound, what we have to do is to find the new value of the previous and the new value of current. So make current be the next Fibonacci number and make what? And then we have to make the previous as the new current, and the new current should be computed. In other words, what we have to do is, you remember the parallel assignment? So the previous will equal to the current, and the new current will equal to the previous plus current. So let's take a look at here. So if we have 1 and 1, okay, we can add them together to have 2, and the new previous will be equal to 1 and the new current will equal to 2. And after that, what we have to do is to do the Fibonacci again, and what's gonna happen, the new previous will equal to 2 and the new current will equal to 2 plus 1, which is equal to 3, and so on. Okay, and at the end we're gonna return current, okay, which represent the smallest Fibonacci number greater than the input argument pound. All right. So guys, some problems, particularly coming from science, engineering, and finance, can be solved by generating a sequence of numbers that eventually reaches a desired number, which is the case here of the Fibonacci series. So if we take a look at the implementation of Fibonacci series again, and we would like to check the Fibonacci of 1, and remember, the function will return the smallest Fibonacci number greater than pound. So what is the smallest Fibonacci number greater than 1 here? That's 2. Therefore, when I check that, this will give me 2. So if I did 2, the function will give me 3. If I did 4, the function will give me 5. If I did 19, the function should give me 21, sorry. If I did 30, the function should give me 34. If I did 35, the function should give me what? 55. And if I did anything greater than 55, like for instance 60, I believe it should give me 89. All right. Okay, so let's go back, and if you remember the function mystery, which is something similar to the assignment, the alogical function. So that function will take a number and will define how many times the number can be halved using an integer division before reaching 1. Okay, so here I don't want you to use the built-in function log as well as ceil. Okay, so basically what we can do is we can use the while loop in order to solve this kind of question. So the mystery 4 should return 2, mystery 16 should return 4. All right, so to solve this kind of question, what we have to do is to start an accumulator, and what we're gonna do is while x greater than 1, all right, so as long as greater than 1, we will do the following. We will floor x by 2 and increase the accumulator by 1. So assuming that we have 16 here, okay? The case of 16. So in the case of 16, here we have x and we have I, all right? So guys, x was equal to 16 and I is equal to 0. Now, is 16 greater than 0? The answer for sure, yes. So that's why we're gonna enter the loop. Now here, that is equal to x floored by 2, okay? And that's equal to I plus 1, okay? So for those who did not understand what do I mean by the shorthand notation. All right, so now the new value of x is equal to what, guys? To 8. And the new value of I will be equal to 1, all right? Now, is x greater than 0? Is x greater than 1? The answer is yes. Therefore, I'm going to enter the while loop again, and the new value of x will be equal to 4, and the new value of I will be equal to 2, because 1 plus 1 will equal to what? Will equal to 2. Now, is x greater than 1? Yes, because 4 is greater than 1. So I'm going to floor it by 2. So it's going to give me 2. Then I'm going to add what? 1 to I. So I will be equal to 3. Now, is x greater than 1? Yes, 2 is greater than 1. So I'm going to enter the while loop again. The new value of x will be equal to 1, and the new value of I will be equal to 4. Now I'm going to check. Is x, which is equal to 1, greater than 1? No, that's false. Therefore, I'm going to return I, which I equal to 4 here in my case. All right? Now the same thing can be applied if I ask you to find how many times the number n can be like quartered, okay? So instead of flooring the number by 2, we can floor it by 4, and we can find exactly how many times the number can be quartered before reaching 1, all right? Okay, another useful implementation of the while loop is to create whatever called an infinite loop, or to loop, or the while loop will run forever, because the condition that we provided will be always true. Therefore, the indented code block will be executed again and again. So infinite loops are useful when the program is meant to provide a service infinitely. So for instance, for this service, like suppose that we would like to define a function called hello2, and this function will ask you to provide your name and then add hello before your name. Okay, so this greeting message can be incorporated to any kind of server. That can be a time server, a web server, a mail server, and so on. So how to create this kind of infinite loop pattern? By stipulating that the while has a true condition all the time. So to implement function hello2, what we're gonna do, guys, we will say while true, input the name and print hello plus what? Hello, and then we reference the function format, and we'll put the name inside the curly bracket, okay? So, but the question is how we can stop this infinite loop. So to stop this infinite loop, we should break it, so, or more precisely, interrupt it. So how we can do that? So we can do that by typing simultaneously Control C using the keyboard. Okay. A while loop should also be used when a program must repeatedly process some input until a flag is reached. A flag is an arbitrary value that is chosen to indicate the end of the input. So let's assume we would like to define a function called cities, and this functions will do exactly whatever going on at the money heist. It will it will create a list at which the items of this list is the capitals of the cities. Okay, so what we can do is like providing an accumulator here, and then ask the user to input a city and to check whether the flag is happening or not. Well, the flag in my case here is the empty string. So while the user did not enter an empty string, we will append whatever he entered here to the list, to the empty list, and we ask the user to enter a new city again, and we will check if he entered another city, that's like the case of Hong Kong, so it's already be appended, or if he entered nothing, that's this case, so the list will will be returned, and that's it. Now if you check this kind of implementation, has a redundant statements that make the code more badly implemented. Okay, so this is an awkward and not quite intuitive. So we can eliminate the duplicate input statements by incorporating both like an if statement inside the body of the while. So what do I mean by that? So here I'm gonna ask the user to repeat. So here I'm gonna provide what like an infinite loop. Okay, and here I'm gonna ask the user to enter the city. So if the entered city is a flagged, okay, then I am gonna return the list. Otherwise, I'm gonna append the city to the list. All right, so let's take a look at this. So as we can see here, while true, and this is an infinite loop, remember, and we'll ask the user to enter the city. If he entered an empty string, we were gonna return an empty list. If not, we're gonna append whatever he entered to the list. Okay, so the last loop iteration stops here, and for that reason the loop pattern in City2 is commonly referred to as loop and half pattern. Okay, so this question is coming from the midterm of 2020. All right, guys, and it asks you to imagine that you have to ask the player to answer quit or no to indicate their desired choice. The game needs to repeat that question until, okay, so the game needs to repeat that question until quit or quit or no is entered. The following code fragment is missing a line of code. Okay, so we are missing a line of code here. Which of the options solve the problem correctly? So as we can see, like choice, and we ask the user to input either to input an answer with quite or no, and what we're gonna do, we're gonna strip. Okay, we're gonna strip the answer, okay, and lower it. So here we have to check, okay, to check something, and then we'll print the choice, okay, and is not an existing option, please try again, and choice will ask the user again and again. So as you can see, this is a half this is this is an implementation of a loop and half pattern, and most of the students fall onto this trap. So most of them, they read it here, the question until quit or no is entered. Okay, so while quit or choice, and they choose option A, and that's not the case, because we need the game to repeat that question until quit or no is entered. So what does that mean? That means while choice is not equal to quit and choice is not equal to no, we should repeat that question, okay? Therefore, the correct answer here is D, all right? While D again, because we would like to game to repeat itself unless the choice has what? Quit or has no. So the condition should be true unless quit or no has entered. So while choice not equal to quit and choice not equal to no. So you have to read carefully. Okay, so the game needs to repeat the question until quit or no is entered. Therefore, option A is not good. And option B also is not good. Why option D? Because the condition will become false if the user enter quit or no, and therefore the while loop will be what? Will no longer be valid, okay? And no repetition will happen. So therefore we need to check that the user did not enter either quit or no, okay? All right, guys. Another kind of statements in Python that provide further control over iteration is the break statement, okay? The break statement can be added to the code block of a loop, whether a for loop or a while loop, and when it's executed, the current loop iteration is stopped and the loop is exits. Execution then resumes with the statement that follows the loop statement. So let's take a look at an example here. So as we can see here, so like here is the implementation of, if you remember, function city2, and we use the f here. So now what will happen here, what's the difference between this one and this one? Like at this statement, okay, if the city equal to what, guys, is empty string, I specify a break. So what's gonna happen? What's gonna happen? I'm gonna go directly to the statement that follows the loop body, which is return list. Okay. So in case the user entered an empty string, what's gonna happen is I'm gonna, the user entered the flag, therefore I'm gonna leave that list, which is something similar to here. If the user input an empty string, I'm gonna return the list right away, okay? Otherwise, the loop will continue, okay? All right. Now, before I explain the pass statement, and just to let you know that the break, pass, and continue statements are control statements that provide further control over iteration. Now let me show you an example here at which I'm gonna okay, so let's suppose that, as you can see here, what's the difference between a break and continue? So the break statement immediately exits the while or the for loop, while the continue statement skip the remainder of the loop suit. So in the while, the condition is then tested to determine whether the loop should continue executing or not. So in a for, the loop processes the next item in the sequence, if any. So let's take a look at this example. So for I in range 100, If the number is equal to 10, break, then what? Then print number end. So what does that mean? That means if I'm gonna reach 10, or actually I'm gonna, if I'm gonna reach, yes, if I'm gonna reach 10, I'm gonna get outside the iteration. Therefore, what I'm gonna do is I'm gonna print number from 0 to 9, as we can see that here. Okay. However, here, okay, so let's say assuming that, you know, like here I did the up to like 10 here, and I did continue. So if the number equal to 5 means continue. What does that mean? Skip. Okay. Okay, skip this and go to the second iteration, or the next iteration. What does that mean? That I'm gonna print the number from 0 to 9, and at 5 I'm gonna skip that number. So let's take a look at this. Okay, so if I say that at 9 here, and then I rerun it again, so I'm gonna print the number from 0 to 8. Okay, as you can see that. All right. Okay, and meanwhile here, if I say if number equal to 4, even though I'm gonna iterate up to 99, well, I'm gonna stop at 3. Okay, so I hope this is clear for you guys, and let's go back to the pass statement. So if you notice in Python, every function definition or every if, for, while loop statement must have a body. So if you did not enter a body, or like a non-empty indented code block, okay, so you must enter a non-empty indented code block. Okay, that's the case of the while statement here. All right, guys. So assuming that we don't wanna implement anything in the indented code block, so what should we do? If we did not add any statement, Python will give us an error. So in order to avoid that, okay, in order to avoid having an error, we can use the pass statement. The pass statement will do nothing, okay? So in rare occasion, when the code in the blocks really doesn't have to do anything, we still have to put some code in it. For this reason, Python provides the pass statement, which does nothing, but it's still a valid statement. All right, guys. So here, if you can see, if and the number is equal to to 2, pass, else print n. So what does that code fragment will do? This fragment will print the odd number only. Okay. All right, so I'm gonna give you this exercise on the slide, and after that I'm gonna do something using the Jupyter notebook, and then I'm gonna conclude the lectures for both Tuesday and Friday. Okay, so remember that the while loop is very useful when it comes to what, guys? When it comes to solving some scientific and engineering and mathematical problems. Okay, so we would like to write a function called approximate the Euler constant. Okay, and this function will take an error as the input and return the approximation of the Euler constant, such that e of I minus e of I minus 1 is less than the error. So what does that mean? If I provide an error rate, okay, 0.01, so as we know that e is equal to 2.7, okay, 1, but after that we don't know exactly how to specify the numbers. Okay, so here is what it should be the output of the approximate function here. And if we provide like an error percentage equal to 0.0000001, the error value should be equal to 2.718 up to 94. For those who doesn't know what is the Euler can be computed by adding 1 over the factorial of the of the numbers. So as we can see, e to power like e0 is equal 1 over the factorial of 0. Remember, the factorial of 0 is equal to 1, otherwise we're gonna get what? Infinity. So this is 1 over 1, which is equal to 1. The Euler can be also computed by like having e1, and e1 is equal to what? e1 will be equal to 1 over the factorial of 0 plus 1 over the factorial of 1, which is equal to 2. And from now on, we're gonna get the fraction, if you notice. So we start by 1, 2, and then we're gonna get the fraction. Okay, e2 will get us 2.5. Okay, e3 will get us 2.6, and so on. e4 will get us 2.7. So basically, guys, you can see that the most accurate approximation of the Euler constant is from e4 up to like e of n, which n can be e of 1000. Okay, so but there is a trend here, if you noticed. So what is the trend here? That each time I'm calculating the Euler constant, I'm adding 1, like I'm adding the 1 over the factorial of the number and the number that comes before it, the number that comes before it, and the number that comes before it. In other words, if we notice that like e1 minus e0 is equal to 1, e2 minus e1 is equal to half, and now we are getting smaller, smaller, and smaller. The value of that error is shrinking. You can see that like 0.166, 0.4166. Okay, given this observation, we can easily implement what? Implement the Euler constant, okay? And in such a way we can approximate it to a given error rate. So as we can see, the like e0 and e1 was equal to 1 and 2, and we will assign it to the previous and the current, okay? So while the error rate, okay, while current minus the previous, if you see that, okay, if you look at that, while the current minus the previous is less than the error rate given by the function, we should compute a new previous and current. So how we can compute a new previous and current? We have to use again parallel assignment, and at which the new previous is the old current and the new current is the old current plus 1 over the factorial over what? Over which number, guys? Tell me, which number? So the number is basically, guys, I. Okay, so what we have to do, because each time we are doing it, we have to increase I, the index of the next approximation, and the previous will equal to the current, and the current will equal to the current plus 1 over the factorial of I. So let's take a look at E3, okay? So at E3, so we have already the, okay, E2, for instance, E2. So we have already the 1 and E0 and E1 as the previous and the current, because they're 1 and 2. And here we added what? 2, because we would like to what, guys? We would like to start looping from 2 and more, okay? And while the difference between the current and the previous less than the error provided by the function, okay, what we're gonna do, the previous will equal to the current, okay, which is equal to 2, and the current will equal to what? Okay, 2, and the current will equal to 1 plus over the factorial of 2. Okay, that's what we have here. And then I plus equal 1. Okay, and we keep what? We keep looping until what, guys? Until we reach the value of a current minus previous greater than the error, then we return the current. Okay, I hope this is like clear for you, and this is one of the most challenging question that you may encounter in this course. Okay, all right, so let's take a look at some, let's wrap up whatever like we covered so far. Okay, so if we go here and if I open the new, like let's suppose that I would like to, like this is my problem. Okay, my problem here, I would like to define a function. Okay, that function, okay, I would like to define a function. That function will take a phrase as an input and return a phrase. Okay, so it's a string and will return a string and return a vowels in a given phrase if a form of a string is entered. Okay, so only vowels like batu. So the vowels character is A, U, and U. So only vowels in GRR, there is no vowels, so it retains an empty what? An empty string. So how we can solve this kind of question? Okay, basically we have to initialize an accumulator and then start looping. So what we have to do is to initialize an empty string, and for each item in the for each character in the string, in the input string, if the character is one of the lower or uppercase vowels, we're gonna add that, we're gonna concatenate that vowel to the string that we would like to return. Okay, and at the end we're gonna return vowels. Okay, now let's suppose that I would like to another implementation. Okay, maybe like Kathleen will ask me about that. So let's suppose that I would like to implement another function. This function called, okay, count vowels version 2, and instead of returning a string, it returns an integer, with which the integer indicates the number of the vowels in the given phrase. So in August we have just U and what, guys? And A, so it returns a 3. So how we can solve that, guys? Simply by what's the most intuitive and what's the most intuitive way to solve this kind of question? By calling this function, okay, on the phrase and finding the length of that phrase. That's it. Okay, so exactly this is how we're gonna solve it. All right, so what we're gonna return, we're gonna call only vowels, and only vowels will return a string of the only vowels character, and we will find the length of those characters. Okay, so let's assume we would like to test it. Okay, guys, and like here print, okay, and here only, okay, let me make sure that I have run, okay, I have run this. So only vowels, and say in my question that I have only vowels, and in only vowels I will say patutu like this. All right, so if I enter that, print only vowels, and this has to be a string, this has to be a string for sure, and boom, enter. So as you can see, it's A, U, and U. If I would like to, instead of print this, I would like to know how many, like here, how many character, like how many vowels in the string patutu. So I say V2 here, V2, and okay, see that, like it has to be V2 like this, and boom. And it's a naming error because what I did only count vowels. Okay, so count vowels. Okay, and as you can see, it returns a 3. Okay, another useful question is, like, let's assume we have this kind of problem. Okay, assuming that like a given string s and return a new string where if a character x is a non-digit, skip it. If a character x is a prime digit, replace with PR. If the character x is a non-prime digit, add that digit x times. So we need here to concatenate and times, concatenate x times, and here we need to replace the replace the prime digits with PR. Okay, so for instance, like the name of the function, okay, I ask you to name the function missify. So let's go ahead and define that function. Okay, so we have missify. So what we have to do first is to use the accumulated loop pattern. So we have to here to like initialize the empty string, and after that what we have to do is we have to iterate over, okay, we have to iterate over each character in the string, and if this character is 2, 3, 5, 7, that means they are prime. What we have to do is guys, to replace that character with what? With PR. Okay, as you can see. So the new string will be equal to whatever was the string and then its PR. Else, if the character is 0, 1, 4, 6, and 8, that's non-prime. So what we have to do is to concatenate the character, you see, by what? By integer, and let's say that I encountered 0, that means I'm gonna concatenate it 0 times. I encountered 1, okay, I'm gonna concatenate it 1 time. I encountered 4, I'm gonna concatenate the character 4 times and add it to my string, and at the end I'm gonna add my string. I'm gonna return my string. So let's take a look at of the function calls that I have provided you. So missify, okay, and let's assume I have here, okay, 1, 2, and 3. Okay, so 1, 2, and 3, it's supposed to return 1, PR, PR. All right, let's check that. Okay, that's perfect. Now let's suppose that we are gonna have like this messify. All right, so messify x minus y, and since the string, okay, like the characters in this string are non-digit, so it's gonna skip all of it, and it's gonna return an empty string. Okay. Okay, and let's take a look at missify what here, missify this one. So 0 has to be what, guys? It will be concatenated 0 time, and 1 will be concatenated 1 time, okay? And 2, it will be equal to PR, 3 will be equal to PR, 4, it will be concatenated 4 times, okay? All right, and 0 will be what? A, we're gonna skip A, and 0 like it will not be concatenated anytime, okay? Because we're gonna just add an empty string, okay? And 1, it will be concatenated 1 time. Therefore, let's take a look at this. 1 PR for 2 and 3, okay? And then 4 will be concatenated 4 times, and then at the end 0, it's an empty string, and at the beginning it's an empty string, and here it's 1. All right, guys, so I hope you will have a very nice week, a successful week at your midterms, and I will catch you in your exam. Have a nice day.